Hello everyone, I'm Teacher Bochen from Kangaroo Study and welcome back to our YouTube channel again. Now, in this video, we're going to discuss this interesting question on prime numbers. So this is a past year question from NMOS 2025. So without further ado, let us take a look at the question together. Now, in this question here, it says that each square here is to be filled with the different prime numbers. So first of all, we know that this must be different prime numbers chosen from the first term prime numbers. So they have listed down the first term prime numbers for us. So exactly 7 prime numbers are used in the numerator. First of all, we know in numerator there are 7 numbers and 3 prime numbers in the denominator. So for denominator, we have 3 numbers. Now the goal is to make the expression, so it's given to us here. You see in numerator 7 numbers, denominator 3 numbers. So we have to make sure that this is an integer. Hey everyone, do we still remember what is an integer? This is just the whole numbers. Okay, so this is another way of saying a whole number. So we have to make sure that this result is a whole number, and they're asking us what is the maximum possible value of x here. So let's take a moment to think about this question. They are given us a fraction. Now, when will the value of a fraction become an integer? So when we think about this, let's take a look at some examples of fractions here. Now, from these fractions, let's say you look at the first one, 2 over 3. So this value definitely is not an integer. Now, 7 over 4. So if you change it into mixed number, you get 1 and 3 over 4. Definitely this is also not an integer. If we look at the next one, 8 over 2. 8 over 2 is just the same as 8 divided by 2. So we know that this value is just 4. Oh, this one is an integer. Now how about 12 over 4? 12 over 4 is the same as 12 divided by 4. So we find out that this result equals to 3. This is also an integer. Now from these numbers, what can we observe, everyone? So we can see that first of all, if the numerator is smaller than the denominator, definitely this is not an integer. And so we know that this numerator, when it's bigger than the denominator, what are the things we need to satisfy? You see in 7 over 4, 7 cannot be divided by 4, so this is not an integer. But for 8 over 2, 8 can be divided by 2, so the result is an integer. And for 12 over 4, 12 can be divided by 4, so the result is also an integer. So the things we can notice is that for the number on the top, the numerator, if it can be divided by the denominator, so we can say the value of this fraction will be an integer here. So now knowing this, in another word, what we can say is that this top number is also a multiple of the number at the bottom. For example, 8 over 2. Right, the numerator 8 is a multiple of the denominator 2. So this way the number is an integer. Then similarly for 12 over 4, since 12 is a multiple of 4, then the value of the fraction will definitely be an integer here. So now knowing this, what can we gather from the question? So let's relook at the question here. Now since we have 3 different values to be filled in for the denominator, and then the 7 values for the numerator. So at this time, we have to make sure that the numerator is a multiple of the denominator. Right? If we try out the number one by one, there are so many choices here. So definitely that's not a very good way of solving the question. So let's think. Throughout this process of selecting the numbers here, what will remain the same? We're going to see that the numerator and denominator, the number keeps on changing. Right? If we try them one by one, use the number numerator divided by the denominator, there are too many things for us to calculate. But there is something that is going to remain the same. You see that we are always selecting from the same 10 numbers here. So if it's from the same group of numbers, this also means that the numerator and denominator, when we add them together, the total is always going to be the same. So then we can see that for numerator and denominator, let's add them together, see what we can get. Right, so denominator plus the numerator. First of all, we know that this numerator just now we say is a multiple of the denominator. So now we have the denominator plus the multiple of the denominator. Now everyone, what can we get from here? If we are going to notice a number plus a multiple of the same number, now it's the result of multiple of this number. Definitely this is also a multiple of the number itself. So we know that when we add these two together, we are also going to get a multiple of the denominator. If this is a multiple of the denominator, how does that help us? Just now we say that this is out of the 10 numbers here, right? If we can find out the sum of the denominator plus the numerator is also a multiple of the denominator, which means that the sum of these 10 numbers is a multiple of the denominator. So definitely this must be a multiple of the denominator here. So now knowing this, let's add the numbers together, see what we can get. So we add the two numbers together, we are going to get 129. Just now we see that this is a multiple of the denominator. In other words, this denominator, it will be a factor of the total 129. So let's check what are the possible factors here. So in order to check the factors, where we've learned it in class, we have to split this number into the product of two individual factors. So for 129, first of all, we can split it into 1 times 129. Then other than this, what else can we try? So we're going to notice that 129 is also divisible by 3. Now, divided by 3, we are going to get 43. Now, is there any other way to split the numbers? So we're going to notice that now 43 is actually a prime number. So when trying it out, there is no other way to split this number here. So now there are 4 different factors. Any of them can be the value of the denominator here. So let's try out one by one, see which of them is correct. Now, if the denominator is 1, is this correct? Definitely we can see there are 3 numbers in the denominator. Now 3 of them added together definitely is more than 1. So the first one, this is wrong. Then let's try. If the denominator equals to 3, is this possible? So we can see that the smallest number we can try 2 plus 3 plus 5. Now these added together, that's already 10. So we know that this part is also not possible. Then let's try out the next one. If the denominator equal to 43, now are we able to get the numbers here? So let's try out the numbers. If we select the smallest, 2 and 3, this gives us a 5. So the last number will be a 38. But we notice that these are prime numbers. Other than 2, the others are all odd numbers. So definitely this is not possible. So the other thing we are going to notice is that if we contain the prime number 2, now the sum of the other 2 numbers will be a 41. So the other 2 numbers add up to 41, it will always be an even number plus an odd number. And since all the other prime numbers, what are they? They are odd numbers. Definitely this is not possible. So now knowing this, we know that can the number 2 be selected? So definitely 2 cannot be selected, or else the total will never be 43. Now knowing this means that all 3 numbers selected, they must all be odd numbers. So we need to select 3 odd numbers. Let's take a look at the numbers here. Suppose we choose the smallest. Let's say we select 3 and 5. Together this is 8. So in order to get 43, it will be 8 plus 35. But 35, this is not a prime number. So this way, cannot. Then let's try 3 and the next number, 7. 3 plus 7 is 10. So in order to get 43, we need to select 33. 33 not only is not given, and is also not prime. So this is also wrong. Then let's try. After 3, 5, after 3, 7, we can try 3 and 11. So 3 plus 11, we get 14. And now 43 minus 14, and we find out the last number, it will be 29. So finally, we have found all 3 of the numbers here. So what we can get is 43 is 3 plus 11 plus 29. And after we find out the denominator, let's look for the value of x. So for this number x, do we have to add the numbers in the numerator together at this moment? Actually, we don't have to do that, right? We notice just now we already found out the sum of all the numbers, 129. Now, if the denominator is 43, how about the numerator? Aha! We can just use the total minus the sum of number in the denominator. Then we can find the sum of number in the numerator. So, to find the value of x, for numerator, it will just be the total 129 minus 43. Where denominator, these three numbers add up to 43. Let's simplify it. So we get this 86 over 43. So the value of this number will just be 86 divided by 43. This equals to 2. Right? So now we find out that d equal to 43. This is actually correct. This can work. But let's not forget about the last choice. If d is 129, how about this one here? If we're going to notice if this is 129, now we have to fill in all the numbers in the denominator. Definitely this is also not possible. So this one is also wrong. Right? So the maximum possible value, in fact the only value we can get from here is x equal to 2. So that's the correct answer here. So now we've understand about this, let's do a quick summary on the question here. Now in this question, we notice that if this fraction, the value of it is an integer, what's the relationship between the numerator and denominator? Right, just now we say that this numerator, it must be able to be divided by the denominator. So in another word, we can also say numerator is what number of denominator? So numerator, this will be a multiple of the denominator. So the other thing we have used just now is that because it's difficult to solve the numerator and denominator separately, so that's why we were looking at the sum of these two numbers. And the reason we can look at the sum is because a number plus a multiple of this number not will be a multiple of this number again. So definitely this is also a multiple of this number here. Right? So for example, if let's say you have a number 5 plus another multiple of 5, let's say 20. So added together we get 25. We're going to realize that this is also a multiple of 5. So knowing these two, right, we can solve any question is in the similar format. So I prepared a question for you. This is from NMOS 2011. And you can notice that this question is very similar to what we have just done. Right? So after the video, right, you can try to solve this question here. And if you got the answer, you can post it in our comment section. Or else, you can also join our group and contact me directly so that we can discuss the solutions together. Of course, if you want to know more about the training in our center, please feel free to join our study group as well. So once again, if you enjoy our videos, make sure to subscribe to our channel here, and I'll see you in the next video. Bye bye!